Hello students, I hope you are having a wonderful day. Today I'd like to make a video over calculating the resultant force and the direction. So we're going to calculate the magnitude and direction of the resultant, and we're going to be using the component method today. So this is number 3 on your assignment using the component method. So this is number 3. In this system of forces we have 2 applied forces. Force number 1 is 440 newtons, and it is applied at a direction of 80 degrees in the first quadrant, and this is with respect to the x-axis. And then we have force 2, 300 newtons, that is applied at an angle measure of 150 degrees with respect to force 1. Now, before we begin calculating anything, what we need to do is set up a table, because we're going to be using vector resolution for both forces. So to set up the table, we need 3 columns, and so we're going to write our headings first on each of the columns. The first one we can say is force, then we have x component, then we have y component. So how many forces do we have in our system? We have 2 forces. So force, we can say force 1, and our second force, force 2. And for the final row, we want to say sigma. And remember, this capital Greek letter sigma represents the sum of. So let's put a bottom double border here. We need to build our table. Now the examples in the book, they do not have a table like this, but especially when we start out, I really think we should go ahead and build a table so we can keep all of our information straight. So let's go ahead and get started with force 1. So we're going to need to redraw the triangle, and the first thing we need to ask ourselves is, do we have the reference angle? So looking right here, the answer is yes, we do have the reference angle. So our reference angle is 80 degrees. So I'm just going to redraw the triangle here. So the force is 440 newtons. We have an x component, and we have a y component. And like I mentioned earlier, we do have the reference angle, which is 80 degrees. Now what we're going to do is use vector resolution. So we are going to break this vector down into its x and its y component. So let's talk about the x component first. We know that the x component is equal to the hypotenuse times cosine of the angle theta. And this is our reference angle here. So my hypotenuse is 440 newtons, and it's positive because we're moving in a positive x direction. So you know all x values in quadrant 1, I'll go ahead and put that there as a label, quadrant 1 are positive. So we are going to have a positive value for this force because it's going in a positive x direction, times cosine of 80 degrees. So what let's go ahead and do, go ahead and get out your calculator. Make sure your calculator is in degree mode, not radian mode. It has to be in degree mode. So we're at 440 times cosine of 80 degrees. This is going to give me 76.4 newtons. Now what we need to do is we need to put this in our table, because the x component of force 1 is 76.4 newtons. Now we need to take a look at the y component. So once again, we're going to perform vector resolution. We're going to break our vector down, 440 newtons at 80 degrees, into its y component. We know that the y component is equal to the hypotenuse times sine of the angle theta. Remember, this angle theta is the reference angle. So our vector is 440 newtons, and we need to ask ourselves, is this being applied in the positive y direction or the negative y direction? Well, taking a look at the illustration given to us, we know that this is in a positive y direction. So we're going to have a positive value for the 440 newtons times sine of our reference angle, 80 degrees. So 440 times sine 80 degrees. This is 433.3 newtons. Now, we need to put that value in our table. So the y component of force 1 is 433.3 newtons. Okay? Now we need to take a look at force 2. So force 2 is here. So what we're going to need to do is we are going to need a reference angle here. Okay? So we need to calculate this angle. First, we need to calculate the angle that force 2 is applied at. So we're going to start our angle right here on the x-axis in the positive x direction, and I've labeled this 0 degrees here. Remember that a counterclockwise rotation is positive rotation. So we're going to start here, and we're going to rotate counterclockwise. So we have 80 degrees plus 150 degrees. So this is going to give us 230 degrees. So I'll just go ahead and write 230 right there. Now, we know that we move past the 180 degree mark. So we're looking for this angle. Okay, so 230 degrees minus 180 degrees is going to be 50 degrees. Okay? All right, so right here, our reference angle is 50 degrees, so we need to redraw our triangle. So we've got .300 newtons. We have an x component, and we have a y component, and our reference angle is 50 degrees. Okay? So let's first calculate the x component. So my x component is equal to the hypotenuse times cosine of the angle theta. Now, for the hypotenuse here, this is our the magnitude of the force. We need to ask ourselves, since it's a vector, we must show both magnitude and direction. So talking about the direction, we have 300 newtons. For the x, are we moving in a positive x direction or a negative x direction? Well, looking at our illustration, we are moving in a negative x direction. And we already know that the x values in quadrant 3 are always negative. So we're going to say negative 300 newtons times cosine of 50 degrees. So on your calculator, negative 300 cosine 50 degrees, I have negative 192.8 newtons. Let's transfer that calculated value into our table here, negative 192.8 newtons. Now let's take a look at the y component. For the y component, y is equal to hypotenuse times sine of the angle theta. So we have a vector here, 300 newtons. Are we traveling in a negative y direction or a positive y direction? Well, right here we're in quadrant 3. It looks like we have a negative y direction here. So we have negative 300 newtons times sine of 50 degrees. And I get negative 229.8 newtons. Now we need to go ahead and transfer that value into our table. Okay? Now that we have used vector resolution to break our vector down into its x and y component, what we need to do is add up the columns, okay? And the answers here will be the x and y component for our resultant. So right here I have 76.4 minus 192.8. This is going to give me negative 116.4. For the y component, 433.3 minus 229.8. This is going to give me a positive 203.5. Okay? So, I'm going to go ahead and erase this here. So, as I mentioned earlier, this is going to be the x and the y components for our resultant. So what we're going to do is, if I had a coordinate system here, we're going to start at the origin, and we are going to create a right triangle based off of our x and y components that we have in our table. So we're starting at the origin, and our x component is going to be negative 116.4. So let's say negative 116.4. This is my x component. And so I'm moving in a negative x direction. Now we don't have to put negative here because our vector arrow is showing us the direction. Okay? We're going to use the head to tail method. Next we have 203.5. So we're going to place the tail of our second vector on the head of our first vector. And this is positive, so we're going to move up 203.5. And we're in units of newtons here. And what we always want to do is draw the x value first, because remember, we need a reference angle. And there is our reference angle there, okay? The first thing we want to do is calculate the magnitude of the resultant. So my resultant here, okay? We're going to use the Pythagorean theorem. So that's going to be, in our case, our resultant squared is equal to our x component squared plus our y component squared. Okay? So our x component, 116.4 newtons. We're going to square that plus 203.5 newtons squared. So 116.4 squared is equal to 13,548.96. And remember, right here, not only are we squaring the numerical value, we're squaring the unit value. So I have units of newtons squared plus 203.5 squared. I have 41,412.25 newtons squared. And right here, we have our resultant squared. Now, we can't just add these values up and say we're done, because we have a squared value over here. And to eliminate that, we're going to take the square root of both sides. So when I take the square root of both sides, on the left-hand side of the equal sign, the square root and the squared cancel out. So my resultant is equal to, we're going to add these two values together. And so I have the square root of 54,961.21 newtons squared. So let's go ahead and take the square root of that value. This is going to give me 234.4. Okay, now let's take a look at the units here. Okay, we're taking the square root of the numerical value. We're also taking square root of the unit value. The square root of newtons squared is just newtons. All right, so the magnitude of the resultant vector for this system of forces is 234.4 newtons. And I'm going to go ahead and label that on my diagram. And on your assignment sheet on number 3, there is a box to fill in your answer. So the resultant vector magnitude, let's place our calculated value here. Okay, now we need to calculate the direction. So right now we do not know what angle theta is. Okay, so we know that tangent theta is the y component divided by the x component. And I wrote our base trigonometric equations right up here. So tangent theta is equal to the y component divided by the x component. And I'm just going to rewrite that over here. Okay, so our y component is 203.5. And we have newtons. And our x component, 116.4 newtons. And we do not need to put a negative sign right here. We're just looking at the ratio here, and our units are going to cancel. The newtons will cancel out. In fact, I'll just go ahead and do that. So what we're going to do is isolate this angle theta, and what we're going to do is take the inverse of this function, which is called arctangent. Okay, so when I have arctangent theta, on your calculator, it's written as tangent -1, okay? Now, what I don't want you to do is think that we can just divide by tangent on both sides of the equal sign. And since tangent will be in the denominator, that's tangent to the -1. So it's like if we had 1 over x, okay? Since x is in the denominator, in order to take that to the numerator, we know that it's x to the -1. That is not the same thing. We are taking the inverse of this function. So what we have is theta equals, and instead of writing arctangent, I'm just going to say tangent with the -1 because that's how it is on your calculator. Arctangent of the ratio of y to x, so 203.5 newtons divided by 116.4 newtons. Okay, that's going to cancel out. So we have arctangent. So if you have any TI calculator, you're going to hit the second function and then your tangent key, and you'll notice that it has tangent with an exponent of -1. 203.5 divided by 116.4, and we're going to get 60.23 degrees. So once again, please make sure that you are in the degree mode and not the radian mode, okay? Now, this angle here, 60.23 degrees. So for our full answer, we have to describe the direction, because if we just put 60.23 degrees, well, we really don't know what that is with respect to. So we're going to say 60.23 degrees north of west. So we have our cardinal directions here, and this angle is north of west. So in our direction, theta is equal to 60.23 degrees north of west. any questions over number 3, please let me know. Feel free to call me, send me an email. I will be more than happy to help you. I hope you have a wonderful day.